We are starting our Saturday session, and as promised, I am recording the part that worth recording for students to view later. And this is a question that came up. So, do you want to go ahead and tell me what is your question for this problem, please?
So yes, I was within in regards to the domain and the range. I
Hmm.
when it says now for the domain, it's um, one and infinity or x such that x is greater than one. But I didn't. I was kind of confused on how how it the number line it shows one right here, but I just couldn't figure out how they got this with a straight line down and then the red line across. I wasn't
Okay.
how that happened.
All right. Let me go ahead and explain that part. Okay. First of all, domain relates to which axis? Can you tell me that?
X, X.
X, very good. So you know that one. So domain relate to X. That's what we're having this X here. This brackets means all the numbers in the on the X axis is X such that this line means such that, and now describing the list of the numbers that we have in the domain. Okay, so this is the notation we use. This is a set builder notation, if you remember, and this is an interval notation. These two are exactly the same, means the same. One is written in the form of interval notation. The other one is a set builder notation. So set builder notation uses brackets, and
Right.
then we indicate, are we talking about the values on the x-axis, or are we talking about the values on the y-axis? So since we're relating this to the domain, you just said domain relates to the value for the x-axis. That's why they put x here. So that means all the numbers such that, this line means such that mathematically. Now this shows all the number that are larger or equal to 1. Okay, so if you look at this graph here, this is a graph that they ask you to find the domain. Now the line that you asked for was to indicate whether it is a function or not. That's called vertical test. You heard of the vertical test on my old lectures?
Yes.
Okay, so the vertical test is the one that when you a straight a line, you draw the straight line on the graph,
Right.
and if that straight line intercept your graph more than 1 point, then you conclude that what you're looking at is not a function, is a relation. So this is not a function, but this one is a function, right? You see, because if I draw a vertical line, if I move this
Are you
vertical line to
done?
the right and left, it's only intercept this graph at 1 point and 1 point only. So this is a function, this is not a function. So the purpose of drawing that line, vertical line, was to identify whether it's a function or not, okay? Because that's what they ask you. It says determine the domain and range after that, and they also wanted to know whether it's a relation or function. So this is a relation. This is a function. Are we okay with that so far?
I can't I can't really see your drawing, but well the question on A was I get that it started at one, but why is the line through on the number line through number three? Like you the blue line is going through three because I didn't see three anywhere. So why would it start at three versus being on the one?
I see what you're asking. Okay, let me say this another way. So if I draw another line like that one, okay,
I can't see your drawing.
do you see it now?
Yes. There we go.
Okay, so this is the line I just drew. Any straight line you draw through your graph. This is my graph right here. Okay, doesn't have to be on three. I'll just put it on two, or I can put it on here anywhere I want.
Okay.
As long as this vertical line intercept your graph at 1 point and 1 point only, then you conclude from there what you're looking at is a function. So the vertical line is only to indicate whether you're looking at the function or relation.
Okay.
Okay, so the first one, as I showed you, intercept your graph more than one point, obviously, right here. So that's why this is not a function. That's my conclusion there. And as you can see, if I draw a vertical line here on the other graph for part B, you see how it would intercept my graph only at one point, only.
Right.
Therefore, it's a function. So the vertical line is only to indicate whether it's a function or relation. We're done with that part, okay?
Okay. And
Okay. So for finding the domain and range, now as you can see, if I extend my graph here, you see how if I extend this is going to gradually get wider and wider and wider, right? As this go on.
okay.
Okay. And it's going to cover all the numbers on the x-axis. Do you agree with that?
Yes.
Okay, so this goes forever, gradually get wider and wider. Therefore, it would cover the rest of the numbers on the x-axis. So that is your domain. Your domain starts from this point right here, which is 1, all the way to the infinity. That's why it's infinity means.
Okay. Okay.
Okay, so now as you can see, 0 is not part of the domain because of that reason, right?
Right.
Therefore, when you showing the domain, if you want to show it in the interval notation, I'm going to use the brackets because the endpoints is included. 1 is part of the domain. So I'm going to put brackets 1, comma, infinity means this, all the numbers after 1 are included as part of the domain for this graph. Do you follow that so far?
Yes.
Okay. Now, if you were going to find the range correspond to the number on the y-axis, right?
Correct.
So as this one increases, like we showed earlier, it's gonna not only cover all the values for the x, also would cover all the values for y, right?
Right.
Okay. Therefore, we say all real numbers, or if you want to write in the interval notation, you could say all the number negative infinity to positive infinity. That's another way to show the range for this graph. Are we okay with that one?
Yes.
Okay.
Yeah.
For the second one, similarly, the domain now would cover all the numbers on the x-axis, right? Because this graph is going to gradually get wider and wider and then covers all the numbers on the x-axis. Are you okay with that?
Yes.
Okay. And the range, however, would be all the number from -1 all the way to infinity. You see that? -1 to all the way to infinity.
All the way up. Okay.
Okay. So do you understand why the purpose of those vertical line, first of all, and how I find the range and domain then?
Yes, the domain is the x, so it's all real numbers there from one to the other, right? -1 all the way past.
Are we talking about part A or B?
Oh, I thought we were on B.
Yeah, so for part B, the domain, like we said, is all real numbers, right? Because this graph going to get wider and wider, pretty much cover everything on the x-axis, right?
Yes.
So that's one way to show it, domain, all real numbers, or like I said, you can write it as this interval notation. Okay, there are different ways you can show the domain is all real numbers. So you can just say all real numbers or show it in interval notation. And the range, we understood that is from -1 to infinity now, right?
Yes.
Very good. So we're good with that problem?
Yep. We're
Okay.
good. I got thrown off because of the red that was already there. I was trying to figure out how do I get that red there, but they already put that there to show the difference between a function and non-function. It wasn't something I had to plot.